Now let's quickly look at a simple example. So suppose we have two bond portfolios, portfolio A and portfolio B. And in portfolio A, we have a 1-year zero coupon bond with a face value of $2,000 and a 10-year zero coupon bond with a face value of $6,000. On the other hand, in portfolio B, we have a 5.95-year zero coupon bond with a face value of $5,000. And we are given that the current yield on all bonds is 10% per year. First, we can show that both portfolios have the same duration. So in order to do this, we will simply calculate the duration and apply the formula. Remember that the first bond in the portfolio A is a 1-year zero coupon bond. The face value times you have the yield is 10% and you have times 1, which is the time to maturity. And for the second bond in the same portfolio, you have face value of 6,000 times, actually this minus 1 comes from 0.1 times 10. So you get e to the power minus 1. And the price of this first portfolio is $4,017. Now we can apply our duration formula. So you need to remember that in the duration formula, we have also multiplication with the payment time. So this is 1 year times face value and the same discount rate, plus we have the face value times, because we will receive this face value in 10 years. So this will be multiplied by 10. And again, you have the similar discount factor here. And you need to divide it by the price of the bond portfolio, which is $4,017. So you can calculate this quantity, and indeed it is 5.95. And notice that this perfectly matches with the duration of the second bond portfolio, because in the second bond portfolio you only have a zero coupon bond. Therefore, the duration is equal to its maturity, which is 5.95. So this shows that both portfolios have the same duration. Now let's look at to the second part. Show that the percentage changes in the values of the two portfolios for a 0.01% per annum increase in the yield are the same for both portfolios. So in this case, notice that to solve part B, actually we can use the duration formula as a first order approximation to find out how much the value of the bond portfolio will change with respect to the change in the yield. And notice in this part B, the yields are assumed to go up by 1 basis point. So 0.01 percentage is also represented or called as 1 basis point. Okay, so this is 1 basis point increase in the yields. And we can easily apply this approximation by multiplying with the duration times the increase in the yields. So this gives us approximately 6 basis points decrease in the value of the bond portfolio. Now we can verify the same change by using the pricing formula for both bonds. And for bond portfolio 2, you can simply compare the old price with the new price. Okay, the new price is obtained when the yield increases by 1 basis point. So you can see that we have updated the yield, it went up, so the new price goes down. So now if you calculate the difference, this is the relative difference with respect to the old price, we find out that exact change is also very close to what we have obtained from the first order approximation using the duration definition. You can also do this for the first bond portfolio. Remember from the previous slide, for the first bond portfolio, the original price is $4,017. Now you need to update the price by increasing the yield by 1 basis point. And you calculate this, which gives you 4,014.6. So if you calculate the relative change just as we did in the previous portfolio, what we get is again approximately 5 or 6 basis points basically decrease in the value of the bond portfolio. And this is not surprising because as we showed in part A, both portfolios have the same duration, and therefore given the same change in the yield, the relative change in both will be almost the same. And since the change in the yield is small, notice that there is one critical point here. The duration approximation works fine in this case. However, if the change in the yield is large, the first order approximation will not be very reliable. So in part C, if we go back here, now the question is what are the percentage changes in the values of the two portfolios for a 5% per annum increase in the yields. This time, this is a much larger increase in the yields, which is 500 basis points, and therefore we do not expect the duration formula to work very well to represent the exact change in the value of the bond. So let's look at this quickly. If the yields increase by 5% per annum, we can calculate the new price just as we did before, and notice that now we added this 0.05, which is the 500 basis points, and now the new price is 2048.2. So now if you compare with the previous price, the decrease is around sorry for this typo, actually there is no zero here, so this is a percentage. It is gonna go down by almost 26%. And if you use the first order approximation using our duration formula, this gives us about 30% decrease. However, the difference between the duration, the approximation obtained from duration versus the exact change we calculated here, now this difference is larger than before. So this shows that as the change in the yield increases, first order approximation is not as reliable as before. You can also do the similar calculation for the first bond portfolio by increasing these yields and recalculating the value of this bond portfolio, and it turns out the updated value should be 3060.2. Then the change in the value is calculated as 0.23, which is around 24% decrease in the value of the bond portfolio for the first portfolio. And again, if you use the duration formula, what you get is same as here, which is close to 30% decrease. However, you can notice that the difference between these two numbers is large. So if you want to improve the accuracy of such an approximation, what we have seen is to use the convexity. So if we use convexity, especially for the large changes in the yields, our approximation will be much more reliable than the first order approximation.